Okay, how's everyone going today? Okay, who here is a developer? Who here is building their own startup? And who here is doing something else? All right, what are you doing? A publishing manager. You build rockets. Awesome. We work with a lot of guys who build rockets. Cool. Okay, so what we're going to talk to you about today is augmented reality and the computer that you're all going to be using for the next 10 years. This is some graphics from Ender's Game you might recognize. It's built by our lead UI designer, Jace Hansen. And you've probably heard a lot of talk about augmented reality recently and seen Google Glass. And we get a lot of questions about whether what we're doing has anything to do with that. And today, I'll show you that augmented reality is a lot more than a Post-it note. It's holograms that exist in the real world. It's the graphics that you've seen in movies. And the reason we know we can bring this to you is the people we work with are the ones who built them and the scientists who spent over 30 years bringing this technology to a reality. So I'm going to talk to you about a few things today. The first is the 3 categories of head-worn displays that you should know about that are going to impact your life. The second is what you need to know about Meta and why it's dominating augmented reality. And the third is the progress that we've made and the applications that are already on the way. So there's 3 categories of head-worn devices that are emerging. The first you know about, the notification machine, Google Glass, and the 10 other clones coming straight on its heels. These are pop-up notifications that let you know where your next meeting is, how to get there, and if you're running late. Google's going to win this category, the notification category, because they already have all the data. The guy running Google Glass, Thad Starner, is not interested in interfaces. He's interested in augmenting memory. And that's what this device will rule at. The next category is the Matrix machine. And you've seen it in Oculus Rift. Put a bucket on your head, and you're transported to another world. Both these devices, the notification and the Matrix machine, are devices that separate us from other people, that separate us from the world around us, that separate us from reality. They're not things we can share. And that's where the natural machine comes in, which is what we're building. This is something that can actually connect people with each other and connect you with the real world around you. And the reason that Meta is capable of doing this is we have the only system that can actually understand the full environment that you're in. A real-time 3D scanner that knows every part of the room that you're walking around in and can attach content not to your eye, but to the real world. Right. We're a team of 30 people in Portola Valley, growing very fast. 6 just a few short months ago. At our helm, Miron Gribbets is in the back there, and Jace Hansen, the guy who made Iron Man. We also have Steve Mann, who invented wearable computing over 35 years ago. And Steve Feiner, who's a pioneer of augmented reality and 3D user interfaces. What Meta's building is the most natural computer available. And I want to show you one of our earlier campaigns marketing our developer unit right now. Thanks. This campaign was launched about 6 months ago. One of the toughest applications for us to work on, to bring to a reality, was the 3D sculpting application. You could take a hologram, sculpt it with your hands, carry it to a 3D printer, and have it manifest as reality in front of you. We built this demo about a month ago. It's getting a lot of press. It won us 3 Best of CES awards from TechCrunch, Tom's Guides, and Disney. And we took it down to Disney and Universal recently to show them what we're working on. I'll show you a video of it shortly. The team that we put together with the scientists who invented this field and the science fiction artists who describe what it should look like is one of a kind. And we raced through Y Combinator 6 months ago and topped it for our batch on all the metrics. And we're growing very fast, as you could imagine. I do recruiting calls about 4 a day. We're growing about 5 or 10 people a month. And I think that could be interesting to some of you people here. The core expertise that we have that no one else has managed to tackle in this space is real-time surface tracking of an environment. And we have a number of PhDs who focus exclusively on this working in the company. What that means is that you can walk into a room you've never been before, recognize the table, the floor, the walls, and immediately augmented content leaps onto it. TV on the wall, Dance Dance Revolution on the floor in front of you, your favorite video game characters running around on the desk. You can pick up Mickey Mouse, squeeze him, he'll squeak. The system is completely gesturally based. It's a 3D input and a 3D output. We have a real-time 3D scanner, and we have stereoscopic glasses. Each lens is 8 times the size of Google Glass, and there's 2 of them. They're also 1/5 the thickness. It's technology taken out of fighter pilot helmets, and this is the first time it's been available under $10,000 to a consumer, and that's just one part of the system. We have one of the most advanced sound engines capable of reproducing 3D sound. That means we have a full pickup array, so we know exactly where sounds are coming from, and we can add sounds to the environment where you experience them from any point in space around you. So you can see graphics anywhere, and you can feel sound coming from any of those points as well, which gives you this amazing illusion that the content that you're seeing is actually real and lives in the space. It's not a pop-up hovering 10 inches away from you. It's an actual real-life thing running around the environment. That's our core technology, and we bring a lot of computer vision expertise to build that. We target the same level of the stack that Apple has done for phones. By that, we mean we aggregate a lot of technologies from other sources, depth cameras, RGB cameras, inertial measurement units, microphones, and other sensors. And we bring them all together into one design and then build an operating system layer on top of them that allows people to build applications. The operating system layer that we use is built on Unity 3D, which has 2 million developers. It's incredibly easy to get started on. You just need to know a little C#. The example that we'll show you in a moment that is a video from CNN was one that a couple of guys who had never touched Unity or our glasses built in 3 months. So I'll show it to you now.
The laptop up here so you can see what Mayron is seeing, and you see 2 images because that's what each eye sees something, so you get that 3D effect, right? So go ahead,
correct. Demonstrate
for us what you're seeing. There's his fingers, and it's time to construct a vase.
I'm now sculpting
correct?
a vase in augmented reality. For the first time ever, I'm creating matter from thin matter, and then what I can do is I can grab the object, just going to click on the got it message.
Even that's amazing, that you're just interfacing with thin air.
This is correct. I mean, this is the Iron Man interface. This is it. I can build, invent as a surgeon, as an architect, as a gamer. I could actually hold augmented reality holograms, stick them on parts of the real world, and touch them with my hands.
Yeah, and I had a chance to demo this as well. It is incredible, and we wanted Mayron to do it. We wanted to get it right here on live television, but it's incredible, guys. I mean, to put these glasses on, and you're grabbing in thin air, and people look at you going, what are you doing? Well, I'm seeing, and as you can see Mayron here, he is interfacing. So let's see, is it on, guys? So go back to the vase and
Sure.
take us to that next step where you grab it.
Definitely. So now I'm grabbing it, moving it around. By the way, this is completely collaborative. So like I showed you before, you can then take the vase from my hand. But for now, what I'm going to do is I'm going to place it in the 3D printer. And as you can see on the top, it's converting it to G-code, which is the code that interfaces with the printer. And then it's going to send, now it's sending it to the printer. And we have estimated time for printing, 25 minutes.
Right.
Now you see this little vase over here. Paul Allen, co-founder of Microsoft, built that yesterday. They're so excited about the fact that we could build this in real time.
So that's how far the technology's progressed. So you've seen the glasses here. They're all full see-through. It's incredibly hard to put 3D images that exist at any focal plane from you in the environment on an optic that's as thin as regular glasses. That's something that's taken more than 10 years to develop and is just one of the key parts of the system that put this together. Every part of this system is the best in its class by a huge margin. This has the most sensors of any device out there. So for anyone building applications, this will give you more power than anything else on the market. There's multiple RGB cameras, depth sensors, a 6-microphone array. This thing is completely loaded, and it's connected to an i5 computer that can actually drive all these algorithms at the level that you need. Because it runs in Unity 3D, the graphics are amazing. It's a full game engine, and you can build things that look like the movies, as we're doing. We have a few special offers for very interested partners who want to put a lot of resource into the product. And that's for Jace, who built Iron Man, to actually build your graphics for you. So that's something we've had a bit of interest from some of the big car companies, from a lot of the space-related companies and rockets. Everyone who's building them is talking to us. The thing that drives us more than anything is the collaborative nature of the technology. The ability for us to be the glue between people and not the dividers anymore. This is a fully collaborative computer. Anyone wearing the glasses can all see the same holograms in the same space. They can reach out and touch them. They can pass them to each other. The new mechanism of sharing is not to throw it up there, but to take it to someone and pass it to their hand. This is technology that requires huge resources from many angles, and what we're doing is building on the backs of all these companies that have built parts of the system, and we're tying it all together. There's a lot of applications, as you could imagine. About half the interest we get of the 600 applications that are currently in development are game-related, and about half are professional applications, medical, conference, fitness, and so on. So we're Meta. We are recruiting on every level of the company right now. We have a very unique live-work environment. You'll see a TC Cribs article go up soon. We're in a huge mansion in Portola Valley where the whole team lives and works. We have a very communal atmosphere. It's a beautiful place to be. And if you're interested in computer vision, if you work with Unity 3D, if you build graphics, if you build videos, if you're involved in legal work, any of these areas and more, we're recruiting for all of them. Right now, I'm looking for a hiring manager to handle all this. Thank you.
All right, I know there's a bunch of questions.
Any thought about putting an HTML5/WebGL stack into the device?
We have the ability to run websites through Unity plugins at the moment. Because the environment is fully 3D, the underlying part of the engine has to be 3D as well. And so WebGL is 3D content, but it's in a 2D plane. So when that comes through to Unity, it makes sense. But to start as a website and a window is not the right ground point of the technology.
While I walk over there, talk to us about price point, what's commercially available and what's not, and what stage you are in production.
Sure. So right now there's two models available. There's the Developer Edition, which is a improved style version of what you saw in the video, and it's going for $667. And there is the Meta Pro, which is the best-in-class device, and it's about $3,500, including a full computer.
I was just wondering, you're using Unity. How many polygons are you guys pushing on your hardware currently?
Sure. It's right now our developer hardware. We're experimenting with various fronts on that. When you buy the developer glasses, you bring your own GPU, so it's what you're going to drive. The promise that we're making is that it's always going to be at least as good as a decent laptop computer, and probably better.
While we pass the mic over here, talk to us a little bit about how the devices communicate with one another, right? You said if you and I are both in the room and we're both wearing this higher level model, that we're seeing the same things in the same space. What technology are you using for that?
Sure. So the way that graphics are visualized is you have a stereoscopic display that can place a hologram at any depth, close to you, far away. And you have an array of sensors, including the RGB, the depth sensor, and the inertial measurement unit that all collaborate together via a sensor fusion approach to understand the environment you're in and keep everything tightly locked to it. So when you put down a holographic water bottle on the table, it stays there. It doesn't travel with you and your glasses. And so because the entire environment is mapped and tracked, when someone else enters the space, the glasses understand the position of them as well. And so you can both look at something from a different angle. You can both reach out and touch it, and we have a bunch of patented methods for ensuring that my hands are different to your hands, and we know who's touching what.
I was wondering if the device was tethered or not, or what sort of battery life you're getting out of it, or how does that work?
Sure, I can't see who's, oh, there you are,
Right here.
behind. Yeah, so the initial device, the Meta Developer Unit, is tethered to the computer that you bring, and the Meta Pro is tethered to a pocket computer, something about the size of a couple of phones, and it's an experience of having a computer that's much more powerful than what you have now, in the form factor of an iPhone with a couple of earphones, so a nice slender cable. The battery life that we're targeting is 6 to 8 hours.
Questions? Oh, I know you got them. Don't be shy.
Hello. Can you take a photograph of somebody and have that person appear? For example, instead of a 2D video, can you then have that photo be 3D of a living human being?
Yeah, we can take 3D photos and 3D video. You can take a snapshot of someone with a full depth map with the actual graphics of them overlaid on the top. It looks very natural. And you can walk around it and view it from any angle. We can facilitate 3D video conferencing with that kind of thing. You can experience someone sitting in the room next to you. The depth map is very, very fine-grained. If you come up to me and you place a movie on my shirt, the movie can wrinkle with the shirt. It's like millimeter down. It's very, very fine-grained depth map.
Talk to us about privacy and what you're doing to allay potential concerns there, like we've seen with Google Glass, like you're talking about creating the form of someone else's body.
Sure. So I think the privacy concerns mostly arise through sort of people's behavior. The context that these devices get used in makes a lot of sense as well. If someone's walking into a bar, walking into a bathroom, wearing a device like this, people feel uncomfortable. The use cases that we're encouraging are indoor collaborative use cases. This is not right now an all-day device. It's a device you put on to do something. And whenever you're working with tools to get a job done, working with a games console to play a game, people don't think that you're doing something else. And that's a big part of it. We are also in a position where we don't have an incentive to try to collect a huge amount of data from people. We're not trying to build Street View. And because of that, we don't want to err on the side of collecting more data. We want to err on the side of collecting less, only what's needed. And we want to make it incredibly obvious when there's any recording going on and really limit that part of the device to something that fits in healthy social bounds.
Hello. So I'm very, very impressed by the presentation. and really excited about what this can do.
Thanks.
Now I'm wondering, because one of your vision was to make sure that this virtual world and persistent world is actually shared between all the people and not separating people like, let's say, notification glasses do. But then you still need this access point. You still need those glasses to see through. And I was wondering, like, of course, my brain is going where it's going is how to open that space so that other people who are not wearing glasses can actually see whatever other people are seeing. And those glasses only allows you or enables you to interact rather than just see.
So because of the level of technology required to interact with this environment, you really do need this huge array of sensors that don't exist in any other device to reach out and touch it. We want to connect people together, and that means not putting a pair of these glasses on someone's head and having them walk out in a world where no one else has them. It means focusing on collaborative group activities where it's realistic to expect that people actually do have the glasses and they can work together around it. Because it's all based in a game engine, there's 100 ways we could make it possible to see reality from someone else's perspective and to share material that way. The ways this will happen will be in one that glues people together, because that's what we're here about.
Can you talk to us a little bit about your user acquisition strategy where you see, I mean, you talked about an array of applications. Where do you think it'll get deployed first, and how and when are people going to start adopting the technology?
We've had a lot of excitement around collaborative data-based applications. Without mentioning companies, the rocket engineer we have here, we've had a huge amount of interest for the idea of being able to just put a 3D model of a complicated engineering part in space around you and just look at it from different angles. The ability to convey information by passing complex objects around a room instead of looking at a PowerPoint presentation is immense. And the ability for people to actually engage with that content and manipulate it in real time means that developments can happen a lot faster than would be required for, say, 3D printing a piece, which could take a few days for something large or intricate.
That was me, sorry about that. Question about your background. So how did you end up getting involved with Meta, and like, what's your story and how you arrived here right now?
Sure, so you might be able to tell I'm from Australia. I had a background in education technology, specifically interface design and how to communicate a lot more with a lot less, to build a natural interface that felt comfortable to be around. And I had worked on a few crowdfunding campaigns related to that. And I joined Meta as a co-founder to build the Kickstarter campaign that got the first developer kits out. And since then, I've taken on the role as Chief Organizational and Chief Marketing Officer in the company, and brought a lot of guys from around the world to help with that.
Can you tell us a little bit about Mehron's background as well? Your other co-founder?
Sure. So Mehron's our CEO. Started work on this a long time ago. He was in a fairly covert part of the Israeli intelligence corps and worked on some interesting technology that had a little relevance to this. He trained under Professor Feiner at Columbia University, who was the first person to publish augmented reality as a term. And he also studied neuroscience. And his position is to build a computer that is cognitively healthy, that enhances our interaction with the natural world and with each other.
Can you, earlier you mentioned there's different industry interesting in using your products. I'm particularly interested in the healthcare and health and fitness space because I'm building a startup to promote the health benefit music and dance for patients.
Great. What does your product do?
Use technology, specific AI to recommend personalized music and dance for patients. So I wanted to know, how do I use, I love your technology, it's, great demo. And I wanted to understand how can I use your glass to build into my platforms. Thank you.
Sure. Well, we're bringing developer kits to market and running a lot of workshops. We're one of the most hands-on companies when it comes to supporting developers. from concept art to finding you developers or business people to work with. There was a question about hardware campaigns and how to actually run them as a Kickstarter. And one of the things we found most useful in that was running a promotion campaign before the Kickstarter. Don't make that your first endeavor. So what we've been doing is building a place where people can share the concept of their applications and actually collect people who want to become customers of that app. So when they go out and launch their crowdfunding campaign, the same way we did, the moment you hit go, there's a couple hundred people buying the product right then. And we want to be very hands-on with that kind of support. We get a lot of interest on the medical front. It's a really interesting space, and the potential for work there is amazing. The regulatory issues associated with it mean that it makes it very hard to move fast in that space. And so what we're doing is focusing on the consumer side of it and building a platform for the professional applications. So we've been thinking about taking, and we get a lot of these requests from all the big medical names that you know of. A lot of Ivy League universities come around to try to connect their medical center with our technology. And what we want to do is take people like yourself who want to build medical applications on our platform and actually be an even greater resource than just a technology for you. We want to give you your customers as well, because we're getting emailed by them every day, and we can't serve them.
Take us 10 years down the road. Are you primarily a hardware company, or is it your software and the way that you're doing augmentation that's most distinctive about what you'll be doing and your integration into our daily lives?
What we're focusing on is the software, keeping everything synchronized with the real world and making it something beautiful that people want to really connect with and use, that fits naturally in their environment, that knows when it's appropriate for content to jump up and when you're talking to somebody and it needs to get out of the way. So we're enhancing that interaction. I think there's so many people working on the interesting hardware in this space that 10 years from now, the product could well look more like a pair of contact lenses or maybe even something more invisible than that. But that's something for a million research labs to work on. And what we want to do is tie together those advances into something that's very friendly to use, which means that as developers and customers even, you don't need a PhD in computer vision to work with this product. You just need an idea and a couple months.
Who should people contact if they want to work with you guys?
It's a good point.
Bug these guys after this. Tell your friends.
Check out the website. We have a great OLARC. It's a web chat thing there. It's usually pretty active. Depending on where you're in, I don't know which the right person for you to contact in the company is. If you jump on the website, you can shoot out a contact and you'll get through to the right person.
Thanks so much. Ben Sand from Meta.